Topics in math, simplifying radicals. All right, so we're going to go over a couple examples and then you guys can work on the assignment. So there's already some examples done kind of in the box here, but when you're simplifying radicals, you guys should have done this quite a bit in Algebra 1, Geometry, and Algebra 2. So hopefully this isn't new to you. But when we think about like what perfect squares go into 75, think about the list of perfect squares. 1 times 1 is 1. 2 times 2 is 4. 3 times 3, 9. 16, 25, 36, and so on. 49. So you always want to kind of write that list of numbers or have it in your head if you don't need to actually write it down. All right, so now we're trying to figure out how to break apart this square root of 75. So think of which perfect square perfectly goes into 75, and we see that it's 25. That's the only one that goes into 75. So we're going to rewrite 75 as the square root of 25 times the square root of 3. So then when we simplify that, we say, what is the square root of 25? It's just 5. So now that we simplified it, we don't need to write the radical around the 25. We can just write 5. And then what is the square root of 3? It's a decimal, so we're not going to write it as a decimal. We're just going to leave it square root of 3. So that's 5 times the square root of 3. For part B, 24, why don't you guys try that one? Figure out which perfect square goes into 24. I'll give you about 30 seconds. All right, the perfect square that went into 24 was 4. 4 and 6. So when you say, what is the square root of 4? It's 2. 2 times the square root of 6. All right, let's go to the next section when we're multiplying. So multiplying radicals, this is a good one to see. If you have it all squared, you can write it twice like this, or you can apply the exponent to each of them. And then if we write it twice, you'll put the numbers that weren't under the radical together. So 2 times 2, that's how you got 4. And then put the numbers that are under the radical together. Square root of 3 times square root of 3 always just equals itself. Like this one up here, square root of 5 times square root of 5 is just 5, because the square root and the square cancel out. All right. So 5 to square root of 5 times the square root of 3, we can write it together under one radical. 5 times 3 is 15. Now if we think of those perfect squares, 4 or 9, none of those go into 15. So then we're just done at that point. Okay, however, for part B, when I multiply them, I get 12. Now I can take out a 4. So I can rewrite it square root of 4 times square root of 3, which ends up being 2 times the square root of 3. All right, I'm going to jump down and do E. So you can either write this, again, write it twice, 3 times square root of 5 times another 3 times the square root of 5, and get what that equals. Or I can square each item. So I can say 3 squared times square root of 5 squared. Either one should get you the same answer. So this one's going to be 9 times square root of 5 squared. Those cancel. So 9 times 5, 45. If I do it this way, 3 times 3 is 9. Square root of 5 times square root of 5, square root of 25, which is just 5. So it's going to be 9 times 5, which is 45. So same answer. All right, why don't you guys try C and D if you haven't already. All right, so C, if we multiplied them, we would get square root of 24, but then we can simplify that to be square root of 4 times square root of 6, or just 2 times the square root of 6. And you could have actually simplified the 8 first, if you wanted to make it 2 square root of 2, then multiply. All right, square root of 7 squared. Again, the square and the square root cancel, so it's just 7. If you wanted to rewrite it twice, you can get square root of 49, which again is 7. All right, let's go to the back. Rationalizing the denominator. So this is the idea that we cannot leave a radical in the denominator. It's kind of like leaving a fraction like with like unsimplified. That one I can take a 2 out of both, so I'd end up getting 2/3. 4/6 is the same as 2/3. So we have to simplify that. This one we have to simplify the same. The idea is the same as this, okay? Only the process is different. So if I think about, the idea is you cannot have a radical in the denominator. So if I think about what would make this denominator not have that square root anymore, that would be by multiplying it times itself. And then that will just give us 5. Well, if I do it to the denominator, just like up here, if I divided the denominator by 2, I have to do it to the numerator as well. If I'm multiplying the denominator by square root of 5, I have to multiply the numerator by square root of 5 as well. So 3 times 5, we're going to get square root of 15 all over 5. Okay, for B, this one's a little trickier because that 12 can be simplified. So I would recommend trying to simplify it first. So I get square root of 12, or square root of 7 over, we can break up that 12 to be square root of 4 and square root of 3. So we get square root of 12, square root of 7 over 2 times the square root of 3. There we go. So now I've got it simplified as much as I can, but again, I have that radical in the denominator. So how can we undo that square root of 3? The 2 is fine. That's not bothering us. It's just that square root of 3 that is. So what we want to do is multiply the top and bottom by that number that's making the bottom have the radical. So we multiply them by square root of 3. So on the top, we get square root of 21 over, and then on the bottom, we get 2 times square root of 3 times square root of 3 is square root of 9, or just 3. So your final answer would be square root of 21 over 6. Okay, go ahead and pause the video and try C. I'll go ahead and pause it. All right, so we can simplify the square root of 25 to just be 5. And then on the denominator, square root of 18 is going to be, you can break that up 9 and 2. And so now we just need to simplify that square root of 2 that's on the denominator. So if I multiply by square root of 2 over the square root of 2, I get 5 times the square root of 2 over, and then 3 times square root of 2 times square root of 2 is just 2. So we get 5 times the square root of 2 over 6. All right, last idea. Adding and subtracting radicals. So in order to add or subtract radicals, they need to be the same number on the radical. So for example, if we look at C, this one is already simplified because the 2 and the 3 are not the same number, so we cannot simplify them. Already simplified. All right, so for the first two, what we need to do first is break apart that square root of 18. So we can break apart that square root of 18 by doing square root of 9, 9 and 2. Square root of 9 times square root of 2. This one stays how it is. So we get 3 times the square root of 2 minus the square root of 2. To add and subtract radicals, you add it the same way as if it said 3x minus x. So we add the numbers out in front. 3x minus, that would be like a 1x, 2, and then leave the x the same. Same thing over here. So again, that's like a 1 right there. 3 minus 1 is 2 times the square root of 2. Okay, so you don't do anything with the number underneath. You just add the number out in front. All right, why don't you guys try part B here? I'll give you about 30 seconds to work on that one. All right, we can break up that square root of 45 with 9 and 5. break up that square root of 20 with 4 and 5. So that's going to be 3 times the square root of 5 plus 2 times the square root of 5. And then if you're adding or subtracting, just again add the numbers out in front. 5, leave the number under the radical, times the square root of 5. Okay? All right, so your assignment is in the packet. It's the radical review on page 13. Let me know if you guys have any questions.